Take out our highlighter. And we're going to learn about combinations today. The key difference between a combination and a permutation is the idea that the order does not matter. So when we're dealing with an example like this, a combination usually means you are choosing a smaller set from a larger set. So in the example they have here, you won a prize, and because you won, there are 4 books, and you get to choose 3 to take home. How many different ways can you choose those 3 books? Well, the order doesn't matter because choosing, oh, I can't decide, should I take book 1, book 2, or book 3, or book 1, book 3, and book 2, it doesn't matter because they're all exactly the same. You still get the books 1, 2, and 3 if you pick the third one first, then the second one, then the first one. It doesn't matter the order, you're still going home with the same books. So in this situation, we have a combination as opposed to a permutation. So with the numbers 1, 2, and 3, if you counted all the permutations, there would be 6 of them. But in combinations, there's just 1. Another possible combination is you choose book 1, book 2, and book 4. But there's a whole bunch of permutations of those same ones. And in the end, if we figure out the totals, well, there's 24 permutations, but only 4 combinations. We know how to count permutations. Permutations, we usually counted with spaces and said, those are my decisions. How many ways can I put a book first? I have 4 choices, then I'd have 3 choices, then 2 choices. And there would be 24 choices in total. But in combinations, you can think of combinations like identical objects. All 6 of these are identical because they're all taking home books 1, 2, and 3. All 6 of these are identical because they're taking home books 1, 2, and 4. And for every permutation, each of these has 6. So to figure out the number of combinations, does it make sense that you would need to divide by 6? In fact, we're taking the 24 and we're dividing out the order. How many ways can you order 3 books? 3 factorial ways. What's 3 factorial equal to? It's equal to 6. And so to calculate the number of combinations, we take the number of permutations and divide out the order because the order are all identical objects. So this is saying the same thing, divide by 3 factorial. If we look at our permutations formula, our combinations formula says just do your permutations formula and then divide out the order. What does that do to our formula? If we substitute in our permutations formula, we get our combinations formula right here, which is n factorial over n minus r factorial, r factorial. And we'll do a bunch of questions using that formula. And unlike permutations, where we almost never use the formula because spaces was easier, in combinations, we will use the formula a lot. On your formula sheet, it's shown as n choose r. If you get into some university courses, they tend to use this notation a lot more. It means the same thing, n choose r. It's just written in brackets with the n on top and the r underneath. So it's just another notation that means the same thing. So if we look at example 1, Keno lottery, 20 numbers are chosen from 80. The order doesn't matter. How many different possibilities are there? And like I said before, we're going to use the formula a lot. If you have 80 items or 80 numbers and you choose 20 of them, you'll write it like this. You'll put that directly into your calculator as the formula. one thing I want you to notice about the formula, you always have the first number on the top of your formula, just like permutations. On the bottom, you will have the 20 factorial plus whatever would add up to the top number. So you'll have 20 factorial and 60 factorial because the bottom two numbers, 20 plus 60, add to the top number, which is 80. And that's always the case with combinations. So I find with numbers, the combination formula really easy to remember because I know the bottom two numbers have to add up to the top number. Find your combination button on your calculator and see if you can get this number. Now, probably the most famous or well-known lottery in Canada is Lotto 649. Have you heard of that one before? Lotto 649 has 49 numbers, and you choose 6 of them. And if you choose the right 6 numbers, you win the grand prize. It doesn't matter the order. So if they choose the 6 numbers in a different order that you chose the 6 numbers, it doesn't matter. You just need to choose 6 numbers. So if we go to our calculator and say, well, how many combinations are possible? We go 49, choose 6, 13,983,816 different possibilities. Almost 14 million different possibilities. So if you buy one ticket and someone found out in the other class that currently one ticket costs $3, you have a 1 in 14 million chance of winning. That is not very good. It's very unlikely. To give you an analogy of what that is similar to, if you take out a coin, and here I've got a penny, and I flip it, see if I got heads or tails, I got tails. If I do this another 22 times in a row on tails, that would be as likely as winning the lottery. You think I can do it? I can't even catch it. Here we go, second time. Tails, 2 times in a row. Oh, heads. Almost. I could go home and practice. How long do you think it would take you to get 22 times or 23 times in a row? A very long time. It probably won't happen. But that's about the same chances of you winning the lottery if you buy one ticket. However, if you really, really, really wanted to win the lottery, if that's on your bucket list, right? I want to win the lottery before I die. You can. All you have to do is buy every combination. Right? So there's 14 million tickets. You just have to go out, $3 a ticket, buy them all. $42 million later, and you will be guaranteed to win. Right? Great idea. Hey, if it gets up to 60 million, you could buy every ticket for $42 million and guarantee that you're going to win. Why might that still not be a good idea? I mean, it's a good idea. I would do that every day if someone said, here, you give me $42 million, I'll give you $60 million. You want to trade? I'd be like, okay. And the next day, you want to do that again? Yeah, I'd do that every day. But what's the problem if you did that in the lottery? Someone else might win, right? And you have to share it. So you go to the bank and you say, could you please lend me $42 million? I'd like to win the lottery. Okay. I have yet to find a bank that says yes to that, but can keep trying. And then somebody else wins, and so you share the 60 million, you each get 30 million, now you're in trouble, right? Because you borrowed 42 million from the bank and you only won 30 million. You could be in a little bit of trouble. But that is a possibility. You could win if you bought every ticket. And there's only 14 million tickets. Now, your chances of winning if you buy one ticket are so astronomically small that you'll never win. However, when enough people buy tickets, if all of a sudden 14 million people buy tickets, now all of a sudden there's a chance that someone wins. Now, some people buy the same number as somebody else. So they're never going to, you know, it's not guaranteed if 14 million people buy tickets that someone's going to win, but there's a better chance that someone will win. And as the pot goes higher, more people buy tickets, and eventually you do have a winner, which makes that person very excited. Okay, questions for practice. 4, 5, and 7.